Today is the second video of explaining ball python genetics, and today we're going to focus on dominant genes. So what's the difference between a codominant mutation and a dominant mutation? There isn't a big difference, but basically getting back to it, the previous video we showed you guys yellow belly to yellow belly produces ivories, and there's a huge difference between an ivory ball python and a yellow belly ball python. Of course, the ivory ball pythons are white. That is when breeding with two codominant mutations. When we breed two dominant mutations to each other, which are exactly the same gene, and we get a clutch of eggs, the babies will all look the same as the gene itself, and some of them might be a super, but there might not be a difference in the animal itself. So in short, in the clutch, there can be an animal which is a super, but it doesn't necessarily look like a super, but when it breeds in the future, it's going to act as a super and might produce everything the same as the gene itself. So let's break it down. So this is a normal or wild type ball python, and this is a sugar or a calico ball python. And as you guys can see, is the sugar comes from the white sides that this animal's got. And this is actually a very very nice expression of the sugar gene itself. So what happens if we breed a sugar to a normal ball python? So the end result will be a 50-50 split. We should get 50% normals or wild type ball pythons and then 50% sugar ball pythons. So what happens if I breed two sugar ball pythons to each other? So like with the previous video, when pairing yellow belly to yellow belly, we should get 50% sugars, we should get 25% normals, and then 25% super sugars or super calicos. The only thing is the difference between the super yellow bellies or the ivories and the super calicos or sugars is you can't see the difference between a normal sugar ball python and a super sugar ball python. Or well, until the date, we haven't been able to identify the supers. So in our opinion, the super calico is exactly the same as the normal calicos or the sugars, and there's no real difference to them. So what happens if we start mixing codominant and dominant mutations with each other? So here we've got an orange dream, yellow belly, enchi, leopard, sugar, female. So this is actually 5 codominant mutations, codominant or dominant mutations into one animal. So this is an awesome animal, and as you guys can see, all of the genes are interacting so well with each other to give an equal base of everything that's involved. Enchi is reducing the pattern, leopard is bringing out this dark contrast, and of course the side patterning of the animal. Yellow belly is giving this increased coloration at the side, the yellowish coloration. You guys can see is the clear belly, and of course the sugar just helps to amplify everything and just make the coloration more awesome. But with this animal, there's a lot of different codominant and dominant genes involved in this snake. So let's go take a look at all of those codominant and dominant genes in the single form. So guys, let's look at all of those genes combined in the simplest form. So here's an orange dream. So she actually just had a fresh shed. So this is just an orange dream ball python, one of the key genes in the previous combo we showed you. Here's a sugar ball python, also a very beautiful animal. This is a very nice expression of sugar. I love the white sides that she's got. Then if we add, of course, yellow belly, let's look at yellow belly in simplest form. So here's just a plain yellow belly. Guys will see the belly there. And then the two other genes is enchi and leopard, of course. So here we've got a leopard. That's the most simplest form. So just a plain leopard. And then last but not least, let's take a look at enchi. And here's an enchi. That's most simplest form. So as you guys can see, it's all real subtle genes, and then if we all put them together into one combination, we end up with this beautiful OD yellow belly, enchi leopard sugar And what an awesome, incredible animal. As you guys can see, is 5 subtle codominant mutations. With the eye, you can't really see a huge difference between all of those 5 genes. But look, when they combine into one animal, such a beautiful snake.